Okay, now we're going to compare fractions. We're going to see which ones are bigger and which ones are smaller, or which ones are greater than, equal to, or less than. Of course, with comparing, we're always going to use our symbols. This one, that one, and the other one. Okay? So, if they asked you to compare 4/5 against 2/5, well, you could probably figure that out just by looking. You're going to say, oh yeah, it's 4/5, and you would be right. It would be 4/5 is greater than 2/5. But how do we know that? Well, it's pretty simple. There's two ways we can do it. First, actually it's the same way, but different ways of looking at it. First, you can draw a picture. You can say to yourself, all right, let's draw the same object twice. Let's say it's a cake again. And now I'm going to split it into the fractions. So this first one's going to be 4/5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So we now have, that's 1/5. That's 1/5. That's 1 out of 5. That's 1 out of 5. That's 1 out of 5. All right, we're going to copy and duplicate. So it has to be equal, right? They have to be the exact same shape, but cut or change into the different fractions. So 4/5 here, this top one, is going to be blue. So this is 1/5, 2, 3, 4 out of 5. And 2/5 is going to be green. 1, 2. So which one has more? Well, it's clear that this one is more cake, or has more eaten, right? So it's very clear that 4 out of 5 is greater than 2 out of 5. Pretty simple, right? This one has 1 empty space. This one has 3 empty spaces. Pretty simple. But what if they are different in the denominator? Well, that's pretty easy as well. All you need to do is change the denominators so that both of the fractions are equal. So here's what I mean. Not equal, that both the denominators are equal. So let's say you have 1/2 and you're comparing it against 2/3. You might say to yourself, oh, that's going to be difficult. It might look like 2/3 is bigger simply because it has bigger numbers, but that's not how fractions work. Remember, fractions are parts of wholes. So what I would do is I would first pick one. It doesn't matter which one you pick. Turn that into a picture. Say to yourself, all right, here's 1/2, right? That's 1 out of 2. That's 1 out of 2. I need to shade it because that's what a fraction looks like. This is 1/2 shaded. Now, remember, to compare a fraction, you need to have it be the exact same picture, but cut into different ways. So I can't draw something that's a different size, right? Because it has to be the same area. So what I'm going to do is I'm going to copy that, and I'm going to change it so that it represents thirds instead of halves. Same size, and now I'm going to switch it into thirds. Boom, boom, right? And the thirds have to be equal. So here is 2/3, right? It is 1, 2, because this is 1 out of 3, that's 1 out of 3, that's 1 out of 3. So already you can kind of see that 1/3, if I placed it over it, right, is bigger than 1/2 by just a fraction, right? By just a hair. So we're right. 2/3 in this case is bigger. Is greater than 1/2. But we need to do this mathematically. So what we can do is say, I need to change 1/2 and 2/3 so that they both have the same denominator so I can compare them a little easier. All I'm going to do is I'm going to pick one of them, whichever one you think is easier. I'm going to choose 1/2 here. And you need to figure out a way to change this denominator into that denominator or into an equivalent denominator. So there's nothing you can multiply that would get you from 2 to 3. But what you could do is change them both so that they have the same denominator. And here's what I mean. 1/2, an equivalent fraction to 1/2, if you multiplied by 3, if you multiplied by 3, would give you 6. And what I do to the bottom, I must also do the top. So 1 times 3 is 3. So I could change 1/2 into 3/6 because it's an equivalent fraction, right? And then I could also change this 2/3, multiply that by 2, multiply that by 2. 3 times 2 would give me 6. 2 times 2 would give me 4. And I could change that into 4/6. So now that they have the same denominator, I can more easily see which one, just like in the top, which one is better than the other. And it's clear, even if I drew a picture, that 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, let's make that a little even. I can see that if this is 3/6, right? 1, 2, 3. 3/6 is bigger than, oh, not 3/6, I'm sorry. 4/6 is bigger than 3/6, or is more than 4/6. 1, 2, 3, 4. Look at that. It's very clear that 4 out of 6 is bigger than 3 out of 6. It's also clear that 3/6 is the same as, look, 1/2. Because if you cut this in the middle, this is 1/2 of the picture. That's another half, right? 3 out of 6. And it's also clear that if you cut these into little sections of 4, 4/6 is the same as 2 out of 3. Watch. This is 1/3. This is 2/3. This is 3/3. Do you see that? That's 1/3, 2/3, 3/3. And so it becomes very clear that that 2/3, these 2/3 right here, are greater than this 1/2. And so those are the ways you can do it. So what I did here is I changed the denominators until they became, I changed the fractions into their equivalent fractions until they had the same denominator. And whatever I multiplied to the bottom, I had to multiply to the top. And that's what gave me my equivalent fractions, and then I could easily compare my equivalent fractions to figure out which one is greater.